Oh, hello. Spare the grammar class hasn't started yet. Where are you, sir? Yes. Hi, everybody. Hi. How are you? How are you? Hi, Jay Lakshmi. Hi, Umer. Hi, Shubkumar. Hi, everybody. Hi. Hi, Amisha. Spare the grammar, everybody. Thank you so much for coming. Thank you so much for coming. As usual, my chat is not refreshing. It is so good when it doesn't refresh. You know, it's so good when it doesn't refresh. Hi, Nihal. Hi, miscellaneous acid. Okay, all right. Hi, Atharva Sharma. Oh, wow. Atharva Sharma class 10 से आ रहा है मेरी क्लास में. Oh. Awesome, guys. Awesome. Good evening, Supriya. Good evening, Sri Balaji. Awesome. Hi, Akshara. Whew, so many of you are here, huh? Karthike, Dharmendra, Umer, Kunal Nayak. Wow. So many of you are here. By the way, guys, if you are here for the first time, on this channel, please like our videos, subscribe to our channel, and hit the bell icon so that you get notifications. Okay? All right. Also share with your friends. Call them. They should be called here. Okay? उन लोग को भी पढ़ाई में मजा आना चाहिए ना, सब लोग को पढ़ाई में मजा आना चाहिए. Okay, all right. So, guys, so can anybody tell me what are we going to study today? Anybody tell me what are we studying today? We are studying. Hi, Akash Dev. We are studying ray optics. Okay, Astha, you are not be able to join the Telegram group. I will try to do something. Okay, today we are starting ray optics. Ray optics, guys. Okay, in optics we have two different chapters: ray optics and wave optics. Both of them are super important. Every year you get questions from that in both JEE and NEET. These are confirmed questions. Okay, this is not a chapter like kinematics ki kabhi question aaya kabhi nahi aaya. There you will always get questions. You will always get questions. Okay, all right, guys. All right, so let's start today's topic, guys. What is today's topic? It is ray optics. Guys. Now, all right. Yes, Astha. Hope I will also have a great time teaching you guys. Hi, Killer Gamer. This is there for board exam, and this is there for more than board exam. Okay, if you're preparing for JEE and NEET, this is for you. But also, I will cover everything from scratch, from basic NCERT. All right. Okay. समझ में आएगा, मजा भी आएगा. Don't worry, guys. Okay. Let's start today's class. Without further ado. Okay, so ray optics start with what is light. Okay, ray optics starts with what is light. Okay, so there is something in waves that you must have studied. There is something called an electromagnetic wave. Okay, there is something in waves called electromagnetic waves. This is a wave made up of electric field and magnetic field. Okay, now these electromagnetic waves can have very high wavelength and also very low wavelength. They can have very high frequency as well as very low frequency. Okay, and they have an entire spectrum, guys. They have an entire spectrum, and this spectrum is called electromagnetic spectrum. Okay, now this has all different types of light. This has gamma rays which comes out of radioactive nuclei when radioactive reactions occur. Okay, nuclear reactions occur. This has X-rays which you use to X-ray your chest. This has UV rays which is used in your RO filters. Okay, water purifiers. Infrared which causes heating effect. Microwave which is used in your microwave oven, and AM and radio waves and everything that you use for communication. Okay, now in this entire electromagnetic spectrum, there's a small band here, guys. There's a small band here. Okay, where is it? Yeah, there's a small band here which is called the visible spectrum. Okay, there's a small band here which is called the visible spectrum, and these are the wavelengths and these are the frequencies that our eyes are able to detect. These have overall 7 different colors. I think everybody knows what are the 7 different colors. Yes, what are the 7 different colors? The 7 different colors are Vibgyor, violet, indigo, blue, green, yellow, orange, and red. I hope everybody understood, right? Everybody knows this. Yes. And if you look at the wavelength of this, the wavelength of violet light is 400 nanometer, the wavelength of red light is 700 nanometer. Okay, if I ask you wavelength of anything in between, you just keep on adding 50. So indigo will have a wavelength of 450 nanometer, blue will have a wavelength of 500 nanometer. You just keep on adding 50 as you go towards right. Okay, this which is visible to us, the region of electromagnetic spectrum which is visible to us is called light. Okay, is called light. The visible region of EM spectrum is called light. Okay, I hope everybody understood. I hope everybody understood. Okay, let's talk about properties of light. Okay, let's talk about properties of light. So properties of light, by the way guys, you will get these notes available. They will be available on the Telegram group. So if you want the notes, you please subscribe to our Telegram group. Okay, all right, now yes, killer gamer, you can watch this video for board exam. Okay, now let's talk about properties of light. Okay, so light is basically oscillating electromagnetic wave. Okay, basically there is an electric field which is oscillating in one direction. Okay, there is a magnetic field which is oscillating in the other direction. Okay, and the resultant is light which is going in this direction. Okay, the resultant is light which is going in this direction. So light is basically, everybody should know, it's an electromagnetic wave which we will study in a chapter called electromagnetic waves. Okay, which we will study this in a chapter called electromagnetic waves. It travels through various different transparent mediums, but also light doesn't require a medium to travel. It can travel through vacuum. Okay, this is the only type of wave that can travel through vacuum. Okay, light waves can travel through vacuum. Okay, now the next thing, what is the next property? If I ask you what is the speed of the light, what is the speed of the light, guys? Can anybody tell me what is the speed of the light? Everybody knows this. Everybody knows this. Atharva Sharma is asking, sir, is light a particle or a wave? Please answer it. It is a doubt. Atharva Sharma, we will talk about it in the chapter dual nature of radiation and matter. Okay. So in this case, what is the speed of the light? What is the speed of the light? The speed of the light is 3 into 10 power 8 meters per second. Okay, this is approximately equal to 3 into 10 power 8 meters per second. But actually there is a formula for speed of light, guys, and we will come back to this formula later. But right now I'm just telling you the formula for speed of light is 1 by under root of mu naught into epsilon. 1 by under root of mu naught into epsilon naught. Have you seen this formula before? I don't think you have, right? But have you seen this symbol before? Epsilon naught. Where have you seen this symbol? In which chapter? You have seen this symbol in the chapter electrostatics. You have seen this in the chapter electrostatics. Statics. Okay, and this is called permittivity. Hello guys, am I there? Hello. Guys. Am I there again? I think I'm there again. Okay. I think so. I think there's some issue occurred with my internet. I think some issue occurred with my. Is it still lagging? Or is it now okay? Still lagging or okay? Oh my god, what happened? It is buffering. Now it's fine. Yeah, refresh the page, guys. It will work. Refresh the page, it will work. Okay, if it's still buffering, then I'm sorry. Okay. Mu naught, guys. Mu naught is called permeability of vacuum. Okay, permeability of vacuum. Alright, what exactly is permeability of vacuum? You will study this in the chapter magnetism. Okay, that is I think the 4th or the 5th chapter. You will study this in that chapter, and its value is 4 pi into 10 power minus 7 Tesla meter per ampere. Okay, so if you substitute both these values, 4 pi into 10 power minus 7 and also 8.85 into 10 power minus 12, if you substitute both these values in this formula, okay, if you substitute both these values in this formula, you will get the value 3 into 10 power 8. Okay, you can substitute and you can check, you will get the value as 3 into 10 raised to the power 8. Okay, so this is the formula for speed of light. We will come back to this, guys. We will come back to this formula when we are studying something called refraction. Okay, when we'll study refraction, we will come back to this once again. Okay, so for now, just remember this formula, guys. For now, just remember this formula. Thank you, Atharva. Thank you. Hi, Harmeet. Hi. How was your thermometer, Harmeet? How was your thermometer? It was very, very good. You chose a good scale. Very good, very good. Okay. All right, all right. So let's do a warm-up question, guys. Tell me, when can we see an object? Is it A or B or both A and B? Is it A or B or both A and B? Everybody tell me, A or B or both A and B. Am I still buffering? I'm still buffering. Oh. Is it A or B or both A and B? A or B or both A and B? Oh. The correct answer is, guys, it's both A and B. Okay, the correct answer is that it is both A and B. Guys, you have to remember, if I have a light bulb, I can easily see this light bulb. Okay, I can easily see this light bulb because it is emitting its own light. Okay, but if I also have, let's say, a water bottle. Okay, I'm not very good at making bottles, but let me try. Let's say I also have a water bottle. I can also see this water bottle as long as there is some light source inside, as long as there is some light source somewhere around. Okay, what happens is this water bottle will reflect the light and we will be able to see this bottle. Okay, for example, if you see this bottle, how are you able to see? Light is being reflected by this bottle. Okay, light is being reflected by this bottle, and that's how you are able to see it. I hope you guys understood. I hope. Okay, but here's the thing, there's a catch. The correct answer is both A and B. Okay, but only if light reaches your eye. Okay, and this is very, very important. It's so obvious, but it's still very, very important, guys. Okay, what did I mean by but only if light reaches your eyes? Okay, so let's say I have a bulb. Okay, and I'm looking at this bulb, and this bulb is giving out light in all directions. I'm looking at this bulb, and this bulb is visible to me, and I'm looking at this bulb from here. Okay, can I see this bulb? Yes, I can see this bulb. But now what I do is I take a box, and I put this bulb inside a box. I pack it inside a completely opaque box. Okay, a completely opaque box. Will I still be able to see this bulb? Yes or no? Yes or no? We cannot see this bulb now. Okay, so we can see an object as long as it reflects light, and as long as it produces light, but that light has to reach our eye. It has to reach our eye. Yeah, I know. Dr. Strange is saying, sir, बहुत obvious hai. I know, guys. I know it is so obvious, but this will become important in some time. Okay, just be with me. This will become very important in some time. Okay, so now there are two chapters in which we study light. Okay, there are two chapters in which we study light. There is something called ray optics, guys, and there is something called wave optics. Okay, what exactly is ray optics? In ray optics, what are we going to do is we are going to take a propagation of light. Think of propagation of light as rays. Okay, propagation of light as rays. Okay, what do I mean by this is basically we will consider, for most cases, we will consider the light going in the straight direction. We'll consider light going in straight direction. Now this light can be reflected, it can be refracted, so it can be bent when it gets reflected or refracted, but afterwards in a medium we will consider it traveling in a straight line. Okay, this is basically an ideal way to think about light. What exactly is going to be wave optics, guys? Wave optics is going to be the next chapter. Okay, wave optics is going to be the next chapter, guys. Hi Hari Sharan. Okay, all right. the wave optics is going to be the next chapter, guys, and what we'll do is here we will see light as waves. We will see light as waves. Okay, now I don't know if you guys know, but does sound bend around corners? Does sound bend around corners? Yes, you have mostly seen that sound bends around corners. Okay, but here we will also go through bending of light around objects, bending of light around objects. Okay, just like it happens with sound, we will see the same thing happening with light. Now we don't see that generally in real life, do we? We don't see that generally in real life. No, 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 Yashvir Jain, only the first chapter will be covered here. Okay, only the first chapter will be covered here. The second chapter will be covered after some days. Yeah. So bending of light, we don't see in real life, because in general the objects in real life are very big. Big compared to what? Big compared to the wavelength of light. Okay, but if my object size is comparable to wavelength of light, then in that case, guys, we will see bending of light. Okay, and that we will study in the next chapter. In the next chapter, we will also study other properties of light, such as polarization and interference. Okay, polarization and interference. Okay, by the way, bending of light around objects, what is that called? What is that called? Somebody told me, what is that? Atharva Sharma is exactly right. Atharva Sharma is exactly right. This is called diffraction, guys. This is called diffraction. Somebody is asking, Fatih Minsa is asking, will I cover the entire 11th portion also? Yes, yes, I do that. I do that 12 to 1. Okay. All right. I hope everybody understood. Okay, I hope everybody understood. I hope so. All right, next, guys, let's define a ray. Okay, let's define a ray. Ray is basically the path along which light propagates, or path along which the energy propagates. Okay, path along which the energy propagates. Propone likha hua hai, propagates. Okay, and this is basically, ray is basically an ideal representation of light. It's the ideal representation of light. Okay, in most cases we do see light acting like a ray, but if ever light is passing through any medium, there are also other things happening which we ignore while looking at ray representation of light. Okay, so now here, if you look in the diagram given below, I have a glass slab. Okay, and it's in the air. Now I think everybody has studied this. Everybody has studied this in class 10th, that when a light ray is incident, okay, it will undergo refraction. Okay, but that's just half the story, guys. What happens is, when a light ray is incident here, it undergoes both reflection and refraction. Okay, and in this chapter we are going to study both of them separately. I hope everybody understood. Okay, sir, we see sun rays. Why? Because Priyanshi, sun rays carry energy inside of them, and our eyes absorb that energy, and that's how we detect it. Okay, our eyes absorb that energy and send signals to the brain that, oh, energy is coming into our eyes. Okay, and that's how we detect that. Okay, all right, Priyanshi, I hope you understood. All right, okay. Now, if we talk about light, let's talk about a beam of light. Okay, guys, what exactly is a beam of light? Beam of light is basically a collection of more than one rays. Okay, collection of more than one rays. Alright, now a beam of light can be of three different types. It can be a parallel beam, it can be a divergent beam, or it can be a convergent beam. Okay, divergent beam as in all the light rays are going away from each other. Convergent beam as in they are moving towards each other. I hope everybody understood. Okay, now let's talk about object and image. I think everybody knows. Rajesh is asking me, sir, do you solve all numericals? Yes, Rajesh, I will solve in some time. Okay, miscellaneous acid is saying, sir, are you left-handed? No, man, I'm right-handed. What are you saying? Yeah. Okay, so object and image. Object and image. Okay, everybody knows what an object is. An object is basically any source of light. Okay, any source of light. Okay, what do I mean by any source of light? Any object is basically anything which can send light rays to your eyes. An object is basically anything which can send light rays to your eyes. Okay, an object can be divided into two categories. An object can be divided into two categories. It can be divided into a category of luminous and non-luminous. Luminous and non-luminous. Okay, you guys know the difference between luminous and non-luminous. Luminous and non-luminous. Luminous objects are those which produce their own light. A light bulb produces its own light. It's a luminous object. This bottle is a non-luminous object. Why? Because it is not producing its own light. It is reflecting a light which is reaching your eyes. Okay, so there are two types of object: luminous objects and non-luminous objects. Okay, and an image is something that forms due to reflection or refraction of light. Okay, image is something that forms due to reflection or refraction. Okay, reflection or refraction by an optical instrument. Okay, by an optical instrument. I hope everybody is following so far. I don't think I'm going very fast or something. I think my handwriting needs a little bit of improvement, but otherwise everything is fine, right? Everything is fine, guys. Everything is fine. Yes, hi Bhupendra. Hi Sudarshan. Yes, correct. Very good, very good, very good. By the way, in this case, guys, if the object is here, the image will be here. Okay, in this case, the image will be here. I hope everybody understood. Okay, now image comes in two varieties, guys. Image comes in two varieties. What are the two varieties of images? Real image and virtual image. Okay, what are the real and the virtual image? Real image, everybody knows the definition. It is which can be obtained on a screen, which can be obtained on a screen. These are the images which are real, and virtual images cannot be obtained on a screen. Okay, virtual images cannot be obtained on a screen. If I have to give real life examples, guys, and this is how I would like to see it. Okay, if I have an object here and a plane mirror here, everybody knows plane mirror. Okay, how will the light gets reflected? Let's say this is one incident ray, this is the other incident ray. After reflection, this went in this direction, this went in this direction. Okay, both of them went like this. If I extend them back, this will be the image. Now in this case, this image is a virtual image. This image is a virtual image. Okay, a virtual image, guys, generally forms when I have two diverging reflected rays. Okay, when I have two diverging reflected rays. Do you see that the reflected rays here, guys, this and this are the diverging rays? Okay, they are moving away from each other. So in that case, the image that is formed is going to be virtual. This is going to form behind the mirror, guys, and you cannot obtain it on a screen. Okay, now what exactly will be a real image in that case, guys? What exactly will be a real image? A real image everybody has seen first in class 10th. I hope you have studied this in class 10th. There is a kind of a mirror that we are going to study later. What type of a mirror is this called? This is called a concave mirror. Okay, let's say this is equal to, this is the focus, this is the center of curvature. What happens? Light ray goes, light ray gets reflected, and another light ray goes, and another light ray gets reflected. Okay, thoda diagram galat banaya maine, you know what, I will just change it to a little bit this. Okay, so let's say this is only center of curvature, the image will be like this. Okay, in this case, if you see this and this, both the reflected rays are this and this. What are the reflected rays? This and this. Sorry, yaar. This and this. Okay, they are the reflected rays, and here I have a converging reflected rays. Here I have converging reflected rays. Okay guys, so whenever I have a converging reflected rays, what happens is that at the point they converge, if I put a screen here, if I put a screen at the point of convergence, then I can see an image forming at that point. In that case, I will see an image forming at that point. Okay, so these are called real images. These are called real images. Okay, in case of a real image, guys, the rays actually meet at a point. Okay, they are converging reflected rays. In case of a virtual image, guys, what happens is that the rays are diverging after reflection and they appear to be coming from a certain point. They appear to be coming from a certain point. I hope everybody understood. I think everybody understood. If you did, give me a thumbs up here. Also, if you haven't liked this video, guys, please like this video so that you can watch it later while revising. Revising. Okay. Now, also, next I have something called real object versus virtual object. Okay, now everybody has seen a real object. Okay, everybody has seen a real object. But what exactly is a virtual object? So first of all, everybody has seen the real object. Still, let's make a real object. If I have kept an object in front of a mirror, okay, like this, if I have kept an object in front of a mirror, then this object is obviously a real object. This object is obviously a real object. Okay, I hope everybody understood. I really hope everybody understood. Okay, a real object is one from which light rays are actually, the incident rays are actually coming out. Okay, these are the incident rays. These are the incident rays. Okay, and they are actually coming out from the real object. Okay, but guys, what exactly is a virtual object? What exactly is a virtual object? Can anybody tell me what exactly is a virtual object? Okay, so what is a virtual object? Understand that. To understand that, you have to be with me. Okay, थोड़ा सा मैं लंबा खींचूंगा, but assume that I have a lens. Okay, everybody has seen lenses before. Assume that I have a convex lens like this. Okay, and I have placed an object here, okay, I have placed an object here. What kind of an object will this be, guys? What kind of an object will this be? This will be a real object. Okay, let's call this object as point A. Okay, and what will happen is that light rays will come out of this object. Very simply, light rays will come out of this object. Other light rays will also come out of this object. Okay, and after refraction, they will probably go and meet somewhere like this. Okay, they will probably go and meet somewhere like this. So light rays will come out, light rays will come out like this, and then light rays will go out like this, and they will meet at a certain point. Let's call this point as B. So this point B, guys, this point B is the image in this case. I hope everybody understood. Okay, if you keep a screen at point B, guys, if you keep a screen at point B, okay, what will happen? This is a convex lens, Sam Niran. We will study convex lens later in the chapter. Okay, so this is a convex lens, and if the image is there, then this is a real image, guys. This is a real image. Okay, I hope everybody understood. Okay, now what I will do is I think yahan tak everything is clear, but now what I will do is I will make some changes. Okay, what I will do is essentially what I will do is I will place a mirror here. Okay, I will place a mirror here. Alright guys, what happened here? I will place a mirror here. Okay, and when I place a mirror here, guys, now these light rays were supposed to go to this point B, but now they will not go to this point B. Why? Because there is a mirror in between, and mirrors will reflect light. So essentially what will happen here, guys, is that the light rays will get reflected. You know what? This is not working. Yeah, color different. The light rays will get, oh my god, the light rays, oh my god, नहीं होगा मेरे से, नहीं होगा. I will make like this only. The light rays will get reflected like this and like this. Okay guys, and instead of meeting at point B, as they would have, what will happen now is that they will meet at point C. They will instead meet at point C. I hope everybody understood, guys. I really hope everybody understood. Okay, so now here is the thing, guys. If you forget about this part for a minute, okay, just forget about this part for a minute. Just forget about this. Okay, just forget about this. Okay, so what is happening here, guys? If you just look at this part of the diagram, what is happening here is, guys, that light rays are converging on the mirror. They would have converged at point B, okay, but instead they get reflected and converge at point C. So in this case, this point B will act as a virtual object. Okay, this point B will act as a virtual object. Where I'm talking about just this scenario. Okay, inside this mirror, if you see, this point B will act as a virtual object. It's not really there, but it appears that if the mirror was not there, there would have been object there. There would have been an object there. Okay, and this point C in this case will be the real image. This point C will be the real image. Okay, I hope everybody understood. Guys, this is a plane mirror. Okay, this is a plane mirror that I have kept. Okay, so in this case, there is something called a virtual object. When do we have virtual object? When light rays are converging on the mirror, and when the incident rays, if you see here, this will be for the mirror, this and this will be the incident rays. The incident rays are converging in this case. Okay, if you see, the incident rays converge. Converge at point B. Okay, when your incident rays are converging, that is called a virtual object. When your incident rays are converging, that is called a virtual object. Okay, if you look at this, this is a real object. Here the incident rays are diverging. If you see here, incident rays are diverging. Okay, so how would you know whether your rays are converging, whether your object is real or virtual? See guys, the light rays which are coming out, if they are diverging, then in that case you have a real object. But the incident rays, understand the incident and the reflected rays. So the incident rays, if they are converging, then you have a virtual object. Okay, I hope everybody understood. Guys, if you understood, please give me a thumbs up. Thank you, Harneet. Thank you. If you understood, please give me a thumbs up, guys. Okay, so now let's talk about reflection. Okay, okay, Subham Kumar, that is how you define virtual object. A virtual object is the one where incident rays are converging somewhere behind the optical instrument, somewhere behind the mirror or somewhere behind the lens. Okay, that type of an object is called virtual object. Okay, alright. Then there is something called reflection. Reflection once again is of two types. Okay, if I have a plane surface, okay, and the reflection is occurring in a very organized fashion, we call this regular reflection. We also call this specular reflection. Okay, we also call this specular reflection. In general, whenever we are forming images, it's always due to regular and specular reflection. But if I have a surface which is not planar at all, okay, then the reflection occurs here in various random ways. Okay, one light ray will go like this, the other light ray goes like this, and the third light ray goes just like this. Okay, light rays are going in random direction, so that kind of a reflection is called diffused reflection. Okay, now you have to remember that image formation in generally occurs in case of specular reflection. Okay, all right. If someone is asking, am I using smartboard? No, I'm not using. Thank you, Dr. Strange. I'm not using smartboard. I am using the Vedantu platform's whiteboard. Okay. Now, guys, let's talk about laws of reflection. Can anybody tell me how many laws of reflection how many laws of reflections are there? How many laws of reflections are there? Ayush Mishra, I couldn't find your, I didn't see your question. Okay. How many types of reflections are, how many laws of reflections are there? One or two or three? One or two or three? There are two laws of reflection, guys. The first one is that the incident ray, the reflected ray, okay, everybody knows what the incident ray and the reflected ray are. Okay, and also at the same time, the normal, okay, at the point of incidence, normal at the point of incidence, okay, all lie in same plane, all lie in same plane. Okay, what do I mean by that, guys? What do I mean by that? So first, once again, you know what, look at my picture and try to see this example. Okay, I hope everybody will be able to see this. Let's say I have a mirror like this. Okay, I hope everybody can see the mirror, and let's say an incident ray comes like this. Okay, an incident ray comes like this. The reflected ray, incident ray, I hope everybody can see. This is the incident ray. देखने के लिए ये रहा नहीं दिखेगा, ये भी दिखेगा नहीं. This is the incident ray. This is the second pen that guys understand, that is the reflected. Okay, then at this point I will make a normal. And let's say this is the normal. Let's say all these three are like this: the incident ray, the reflected ray, and the normal. Okay, then they all, guys, they all have to lie in the same plane. Basically, if you look at them like this, they will all lie in the same plane. They will all lie in the same plane if you look at them like this. Okay, it's not possible to have a picture like this where if you see the normal is going out of the plane. Okay, it's not possible to have a picture like this where the normal is going out of the plane. All of them have to be in the same plane. Okay, that is the first law of reflection. Now, it might not seem very important, but it becomes very, very important. It becomes very, very important when we talk about light rays in vector terms. Okay, there are advanced questions which come basically on this principle. Okay, which make use of this principle. And the second, I think everybody knows the second one. It's very simple. Angle I is equal to angle R. The angle of incidence, sorry, the angle of incidence is equal to angle of reflection. Okay, everybody knows this. Angle I is equal to angle R. Everybody knows that? Yeah, I think so. I think so. I hope so. Everybody knows that. Okay, now a simple question, guys. A very simple question. I want everybody to give me the answer. Everybody to give me the answer. Jaldi, jaldi, jaldi. Miscellaneous acid is asking, sir, when will we study multiple reflections? Miscellaneous acid very, very soon. I think in about, I have planned, but I don't remember now when it will be. Very, very soon, man. Very, very soon. Not to be afraid. Okay, a light ray strikes a reflective surface at an angle of 56 degrees. Wow, find the angle of reflection. Can anybody tell me what will be the angle of reflection? What will it be? 56 or 34? 56 or 34? Anybody? See, you have to read this question, guys. It's a trick question. If I have a mirror like this and a normal like this, a light ray is coming like this. Okay, you have to understand that the angle 56 degrees is made with the surface. The angle 56 degrees is made with the surface. What does that mean, guys? What does that mean? Oh, that means that this angle is 56 degrees. That means that angle is 56 degrees. I hope everybody understood. Okay, and in that case, the light ray will go like this. So in this case, what will be the angle of incidence, guys? What will be the angle of incidence? This will be the angle of incidence. Okay, and this will be the angle of reflection. Now you have to understand that this entire angle, okay, will be 90 degree. Why am I saying that will be 90 degree? Because this is the normal. Okay, so the normal is always perpendicular to the surface, so the entire angle will be 90 degrees. So I can very simply say I plus 56 degrees is equal to 90 degrees. So I is equal to 34 degrees. So in this case, guys, what will be the value of R? R also 34. गलती कर दी ना, गलती का सबने गलती, अरे झूठ मत बोले यार, गलती तो की थी, गलती तो की थी, I think गलती की थी. Okay, guys, give me a thumbs up if you understood. Okay, alright. So next is yes, Savarinath, you are correct. Surender Singh is correct. Very good, guys. Very good. Okay, silly mistakes. I know, silly mistakes. So that's why these questions are there, just to induce your silliness. Okay, plane mirror. I think everybody has seen plane mirror in their life. Everybody sees a plane mirror every day in their life. Okay. All right. How do we represent a plane mirror? How do we represent a plane mirror? So you have to remember the representation of a plane mirror is like this. Okay. In this case, we make a single line and we draw hair-like structures on this side. Okay. So one surface is called the reflector surface and the other surface is called the polished surface. What exactly happens is that if a light ray falls here, very good, it gets reflected according to the laws of reflection. But if a light ray falls here, it will either get absorbed or it will get reflected in a random direction, or so many different things happen. Okay, so light ray will never fall on the hair wala side. Okay, it will never fall on the right side, it will fall on the left side or on the reflector surface. Okay, it will always fall on the reflector surface. I think this was obvious, everybody knew this, but still, you know what, you have to say all these things. Okay, I can't miss this, so I will just say it. I just said it. Okay, all right, guys. Next, how is image formed in case of a plane mirror? How is image formed in case of a plane mirror? Okay, and this is interesting, guys. Pay very close attention. Okay, so what happens is, let's say I have a mirror like this, and at the same point of time, let's say I have an object like this. Okay, and this is the object is somewhere here, and you are an observer, you are trying to see the image of this object, okay. So how will the image of this object get formed? Okay, how will the image of this object get formed, and what happens exactly? So what happens is that this object gives out light rays, and those light rays travel in all directions. Okay, the object gives out light rays and those light rays will travel in all directions. I hope everybody understands that those light rays will travel in all directions. Okay, but we are not interested in that. What we are going to do is we are going to see if any of those light rays fall on the eye of the observer. Okay, so if I make a light ray from here, what I can do is I can apply a law of reflection here. The light ray after reflection will go like this. Okay, and if I make, let's say, one more light ray here, I can apply laws of reflection, and after reflection the light ray will go here. Now if you see, the eye was big enough, मैंने बहुत ही छोटा eye बनाया, but if the eye was big enough, both these light rays would have fallen on the observer's eyes. Okay, and what will happen is that in this case the observer will think that, oh, this light rays, they look like they are coming from this point. This light ray, they look like they are coming from this point, and this point where they look like they are coming from will become the image. This point will become the image. Okay, I will provide the notes. Shubham Kumar, do not worry. Okay, Umair is asking why you should not be used digital board instead of whiteboard. I will use digital board as well. Do not worry, Shubham Kumar. It's ordered. It's already ordered. It's on the way. Okay, aa jayega. Do not even worry. Okay, so this is the situation. Now remember, every time you have to form an image of an object. Okay, every time you have to form image of an object, you always have to do this. You have to remember that out of the object, the rays are coming in all directions. How many rays can we make out from an object? We can make out rays, infinite number of rays coming out of an object. Okay, but we don't need to make all of those infinite rays. We do not need to make all of those infinite rays. We just need 1 and 2 two rays coming out of the object getting reflected from the mirror. We just need two rays coming out of the object getting reflected in the mirror. Okay, guys, notes will be given. Thank you, Sneha, but notes will be given in on the Telegram group. Okay, so if you haven't joined our Telegram group, please join our Telegram group. The link for it is in the description. Okay, all right. So image formation के लिए always take out two rays, okay, and see after reflection how they are going. Okay, if they are diverging after reflection, you have to extend them in the backwards direction and you will get the position of the image. That is it. Always take out two images from any of two light rays from any object. Okay, but what kind of an object is this? What kind of an object this is? This is a point object. Okay, what if I don't have point object? Okay, what if I don't have point object? Thank you, Sam Niran. Thank you. What if I do not have point object? What if instead I have a big object like this arrow? What if I have a big object like this arrow? So in that case, such an object, by the way, is called an extended object. What you have to do, guys, is in this case, you have to take each point on this object. Okay, in this case we'll just take the top and the bottom point and try to find image of all those points. Okay, so if I talk about image of point B, I will take out two light rays from point B. I will see where the reflected rays are going. The first reflected ray is going like this, the second reflected ray is going like this. If I extend them back, they will meet at point B. Similarly, for point A, I will take out two incident rays. I will look at the two reflected rays. Okay, I will extend the two reflected rays back and they will meet at point A dash. So this point will be image of B and this point will be image of A. This way you will have to calculate, you will have to find the image of multiple points and then you can just join in between and this will be the entire image. Okay, this will be the entire image. Okay, so if you ever get a big object and you don't know how to make the image of this, start with one point on the body, then the other point on the body, then the other point on the body. Okay, that is how you will get the image of an extended object, guys. Okay, now if we talk about the properties of an image in case of plane mirror, what are the different properties of image, guys? What are the different properties of image? You have to remember each and every one of them. So first one is very simple. That for a plane mirror, the object distance is equal to image distance. For a plane mirror, the object distance is equal to image distance. If you see in this case, this distance will be same as this distance. I hope everybody sees that. Second one, once again, these are obvious properties, guys. I'll just write them down, but everybody I think already knows them. The second is that object size will be equal to what? The object size will be equal to the image size. Everybody knows that. Everybody should know that. I hope so. Okay, Anurag Singh is asking, sir, will I cover the whole optics chapter up to JEE Mains level? Yes, Anurag Singh, I will do that. Okay, all right. The third is object size, image size, object distance, image distance. Then I have the third one, the image is erect. Okay, the image is erect, E-R-E-C-T. Erect as in upright. Erect as in upright. If the object is like this, the image will also be like this. This is called an erect image. Okay, then you have image is virtual. Okay, in case of a plane mirror, and also for real objects, for real objects, the image is virtual, guys. The image is virtual. Okay, and finally, everybody should tell me what is the last one. Thank you so much, Kartikeya. Thank you so much, Shikha. Thank you so much. Okay, anybody tell me what is the last one? Dr. Strange, tell me what is the last one. Okay, everybody. Ayush Mishra is asking, sir, always two rays, not more than that. Ayush Mishra, you can take more than that, but you don't need more than that. Okay, two is enough. The last one, guys, is correct. It is going to be laterally inverted. Okay, it is going to be laterally inverted. What do I mean by laterally inverted, guys? Everybody should know what is laterally inverted. If I have a mirror here, guys, and I keep an object which is A, an object which is in the shape of A, its image will also be A. But if I keep an object which is in the shape of B, if I keep an object which is in the shape of B, then what will happen? Its image will be in the shape of this. This is called lateral inversion. This is called lateral inversion. Left looks like right, right looks like left. Correct, correct. But in this case, you have to remember the image is inverted only in horizontal direction. In the vertical direction, it still remains the same. Okay, it doesn't get inverted in vertical direction, it gets inverted in horizontal direction. I hope everybody understood. Okay, now everybody can tell me, is this yes or no? The answer to this question: can a plane mirror form a real image? Can a plane mirror form real image? Yes or no? Yes or no? Yes or no? Everybody, give me the answer. Yes or no? B B B B B B. Yes. A. B B B B B B. A. Everybody tell me, yes, no, yes, no, yes, no, yes, no, yes, no, never, ever, 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 no, 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 B. Are, re, 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 re. Okay, okay, guys. See, that's the thing, that's the thing. The correct answer is not no, guys. The correct answer is yes, yes, okay. It will form a real image, it will form real image of virtual objects. It will form real image of virtual objects. Okay, what did you say, sir? See, guys, I defined virtual objects some time ago. If you are just joining me now, you have to remember, if I have incident rays, okay, if I have incident rays converging like this, okay, both these are incident rays, then they are converging like this, then we can say that okay, they might have meted at this point if the mirror was not there. In this case, this point is called a virtual object. This point is called a virtual object. Then these light rays after reflection will meet at this point. Okay, and this point here will be the real image. This point here will be the real image. Guys, remember, yes, Khushbu Prajapati, it will form a real image for virtual objects. Okay, now the next question everybody knows. Next question everybody knows. Okay, can a plane mirror form a real image of real image of a real object? Tell me this. Tell me. Can a real plane mirror form real image of a real object? Yes or no? Yes or no? Yes or no? Yes or no? Yes. This time the answer is no. Okay. This time its answer is no. For real objects, it always forms. For real objects, it always forms a real image. Okay. For real object, it always forms a virtual image. Okay. I hope everybody understood. I hope everybody understood. I hope everybody understood. Okay, now guys, this is second question. Okay, I have a mirror like this. Okay, if I draw the top line of the mirror, it is something like this. Okay, if I draw the top line of the mirror, it's something like this. The fly is above that top line. Now the question is, will the mirror form an image of this fly? Will the mirror? Shravani, you can join the group, the Telegram group, and get the notes. Okay, tell me, will the mirror form an image of this fly? And the correct answer is yes, guys. The mirror will form an image of this guy. Of the mirror will form an image of this fly. That is correct. That is exactly correct. Very good, guys. Everybody knew this. Everybody knew this. What will happen is that you can say that these two light rays are coming out of the fly. Okay, and they will get reflected. And if I extend both these light rays, Okay, then this will be the image of the fly. This will be the image of the fly. The image will still be made, guys. The image will still be made. Okay, but now let's say I have two observers, observer A and observer B. Tell me this, guys, which observers will be able to see the image of the fly? Which observer will be able to see the image of the fly? Your options are A, B, or both A and B. Which of them will be able to see the image of the fly? Which of them will be able to see the image of the fly? Will A will not be able to see? A will not be able to see? Will it be B or both A and B? B or both A and B? Yes, B or both A and B. B or both A and B. The correct answer is, guys, the correct answer is only B. The correct answer is only B. Okay, A will not be able to see the image of this guy, of this fly. Okay, why is that? Why is that? Why am I saying that? So then, guys, you have to understand that if you look at all the incident rays which fall on the mirror, all the incident rays, okay, I won't make all of them, but I will make a few of them. If you make all the incident rays which fall on the mirror, then after reflection, they will all go in random directions like this. Okay, so if you see, for you to be able to catch a reflected ray, for a reflected ray to go into your eyes, you have to be in a certain region. For a reflected ray to be able to go into your eyes, you have to be in a certain region. What region do you need to be? This region do you need to be. Okay, this is the region. You need to be in this region. You need to be here for reflected rays to reach your eyes. Your eyes. Okay, and you can only see the image, guys. You can only see the image if reflected rays are going into your eyes. Okay, this guys will not receive any reflected rays, will not receive any reflected rays, any reflected rays. Okay, so therefore he will not be able to see, he will not be able to see the image, he will not be able to see the image of the object. Okay, he will not be able to see the image of the object. I hope everybody understood. Okay, guys, now here Bhanu Prakash is saying, sir, please do advanced level question solving after session completion of a chapter. Bhanu Prakash, at the end of the chapter we will probably do some advanced level questions. Let's see. Okay, in this case, guys, by the way, this entire region shaded in green, this entire region is called field of view. This entire region is called field of view. Okay, this you have to be in this region, in the shaded green region, to be able to, thank you Asta Mishra, to be able to see the image. Okay, hi Pushpakani, I'm okay, I'm okay. Alright guys, now before we get to the next question, guys, before we get to the next question, I have to make you understand. Okay, if I ask you to draw the field of view, if I ask you to draw the field of view, okay, for any case, then you have to remember that you have to trace, you have to find the region where all the, you have to find the region where all the incident reflected rays will be. If I have an object here and a mirror here, how do I find the field of view? How do I find the field of view? What I do is I will start an incident ray from here, okay, and an incident ray from here. Now these two incident rays are special, guys. They are going to the extreme end of the mirror. They are going to the extreme end. That is, remember, okay, extreme ends of the mirror. Then what I will do is I will take a reflected ray from here. Atak gaya. Okay, I will take a reflected ray from here, and also I will take a reflected ray from here. Okay, and if you see, guys, in between these two rays, in between these two rays, all the other reflected rays will be. All the other reflected rays will be in between these two rays. Okay, it will be in between these two rays. Okay, so this entire region, guys, is called field of view. This entire region is called field of view. Okay, I hope everybody understood. Whenever you have to draw field of view, always take two incident rays to the two extremes. Always take two incident rays to the two extremes. I hope everybody understood. Thank you, Surinder Singh. Thank you, Afra. Thank you, guys. Thank you. When will syllabus be complete? Bhaskar Gautam is asking. Bhaskar, January. Okay, alright guys. Now next question. This is a warm-up question. Okay, everybody should know the answer to this question. Everybody should be able to give me the answer to this question. So I have two triangles wherein this angle is 30 degree and this angle is also 30 degree. Okay, the second angle is 55 degree. Okay, not 55, 65 degree. Okay, and the second angle here is also 65 degree. Okay, and this side length is 3 meters. Okay, this side length is let's say 5 meters. Okay, this side length is 2 meters, this side length is x, this side length is this side length is 4 meters. Okay, I don't know what this side length is. Okay, but you have to find out the value of x. You know what, let's not find y because I don't know the angles correctly. Okay, let's give me the value of x, guys. Give me the value of x. Can you tell me the value of x, guys? Everybody, can you tell me the value of x? Can you? Yes, Balaji S is saying that the value of x will be 2. Dr. Strange is saying it will be 10 by 3. How do we solve this, guys? How do we solve this? You have to understand that these two, you have to understand, guys. Where am I? Yeah, these two triangles will be similar. Okay, so I can write that triangles are similar. Okay, and if the triangles are similar, because all three angles are same, okay, therefore what I can say is that 2 divided by 3 meter will be equal to x divided by 5 meter. The ratio of sides in this case remains the same. Okay, in this case what I can say is x is equal to 10 by 3 meters. I hope everybody understood. Yes, everybody understood. Okay, this is the properties of similar triangles. Now guys, I have to end this class soon. Okay, so let's do one question very quickly. What I have is, I have a source of light here. Okay, I have a source of light here and a mirror here. Okay, this mirror has a length of d and it is kept at a distance of L from the source. Okay, now also I have a path here. And a man is walking on this path. Okay, and a man is walking on this path. This path, by the way, is parallel to the mirror and is at a distance of 2L from the mirror. Okay guys, so now the question is, find the greatest distance over which the man can see the image of the source. Find the greatest distance over which the man can see the image of the source. Okay guys, so how do we solve this question? All right, Dr. Strange already knows the answer. Oh my god, such a show off, huh? But yeah, Dr. Strange is correct. He is correct. Okay, how do we find this, guys? Okay, so what do we do here? We will चिपक इधर. हाँ, what नहीं यार, what we'll do here is we'll take out the incident rays, two incident rays to the two extremes. Okay, and let's say after reflection they go here and after reflection they go here. Okay, something like this. Alright, the two incident rays and the two reflected rays. Okay, where are you? Yes, get selected. Incident rays, reflected ray, incident ray, reflected ray. Okay guys, so what I can say is that as long as the man is in between these 2 points A and B, as long as the man is in between these 2 points A and B, he will be able to see. Thank you Sir Chance, thank you, thank you, thank you. As long as the man is between these 2 points A and B, he will be able to see, he will be able to see what? He will be able to see the image of this source. Okay, he will be able to see the image of this source. Where will he see the image of this source? At this point, S dash. Okay, so now how do I find the length AB? For that, what I will do is I will drop a perpendicular here, I will drop a perpendicular here, and I will draw this line here. Okay, and just for the sake of complexity, just to make everything complex, let's just name all the things. Okay, this is A, B, let's call these points C and D, let's call this point E and F, and let's call this point G and H. Okay, now if you see guys, if you see from this, if you see very simply, if you see from this that triangle BCG, triangle BCG will be similar to triangle SEG. Okay, triangle BCG will be. Is this lecture good for NDA, Kartike? I think so. The things that you understand here will be helpful there, but we are aiming mainly for JEE and NEET. Okay, so these two triangles will be similar. Why am I saying that? Is because if you see the first triangle I'm talking about is this, and the second triangle I'm talking about is this. Okay, both these triangles are going to be similar. Okay, guys, I'll end the lecture within 5-10 minutes. Okay, so here both these triangles will be similar. Why? Because the angle of incidence will be equal to angle of reflection here, and this angle will be 90 degrees, this angle will be 90 degrees, so these two triangles will be similar. Am I talking too fast? Yes, probably. Okay, so what I can say is that therefore BC, the length BC divided by the length GC is equal to the length SE divided by the length GE. Okay, now I don't know if you guys can see this, but the length SE will be equal to D by 2, the length GE will be equal to L, and the length GC will be equal to 2L. If you substitute all of them here, you will get BC upon 2L is equal to SE, which is D by 2 upon L. Okay, from this, if you see, you get BC is equal to the length BC is equal to D. So guys, if you see, this length is going to be equal to D. Now, if you check, if you do the same process once again, you will also find that this length is also equal to D. Okay, if you do the same process, you will say this length is also equal to D. So what will be the total length? I already know that this length will be same as this length, which will be nothing but D. So what will be the total length AB? The total length AB will be D plus D plus D. That will be 3D. That will be 3D. I hope everybody understood, guys. I really hope everybody understood. If you did, give me a thumbs up. Give me a thumbs up. Okay. And before you go, guys, let's talk for 2 minutes about the platform of Vedantu. If you are preparing for JEE and NEET 2021 and 2022, Vedantu's platform is just for you guys. If you take a pro subscription on Vedantu, what happens is you get full access to all the live courses. You get to choose the language in which you want to study. You get all the doubts you want to solve getting solved in the class. You get to learn from the best teachers of India, 5+ years of experience, and you get to learn from home. Okay, all subject covered in great detail. By the way, if you miss any chapters, you can just do micro courses. They are also free for you guys. You can take as many micro courses as you want. Okay, if you want to take a pro subscription, guys, these are the prices. These are the original prices. For 1 month is 6,999, but if you take for 12 months, it will be cheaper. It will come out to 31,000, which is just per month price of this. Is if you divide it by 12, it's much less than 6,999 per month. Okay, but also if you want even more discount, if you're like me, if you're like me, and if you want even more discount, what you can do is you can use my discount code. What is my discount code? AAPPRO. AAPPRO. This is my code. If you use this, you get 15% more discount. Okay, Oh, sorry. If you get 15% more discount. And how do you use this discount? You go to vdnt.in/ytpro and use my code AAPPRO. Guys, if you want to study for JEE and NEET, this is a based platform. You can do that. Okay. I will NEET Avenger. I will post the notes in Telegram group. Do not worry. Okay. All right. Now for the last thing, guys, this is the homework question for today. The same question. I'm just going to change the data a little bit. This is going to be L and this is going to be 2L now. The man is still walking on the path. The man is still walking on the path and this length is D. You have to find the same question. You have to find the maximum length for which the man is able to see the image of the source. Okay, you are supposed to find the maximum length of this for that. Okay, Adarsh Srinivasan is giving me the answer. Adarsh will talk about that question in the next 12 to 1 class. Okay, thank you so much. Thank you so much for being here, Pushpakarini. Please come here again tomorrow, guys. We'll continue from this point. Okay, we will continue from this point and we'll have a lot of fun. Okay, guys. All right. Doctor Strange is already giving an answer. Doctor Strange. No, 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 no. Don't give me the answer here, guys. Comment the answer. Comment the answer. Okay. In the comment section. And whoever comments first, the correct answer, whoever comments first. Okay. I will take his name in tomorrow's lecture. Okay. Take his or her name in tomorrow's lecture. Okay, if you're not able to join the Telegram group, guys, I will take a look into it. But if you join through the link, you should be able. Okay, you should be able to join. Raihan B is asking me, am I using BC Pandey? Raihan, I love that book. I really love that book. Okay, but I'm not exactly following that book. I'm following a bunch of different books. Okay, all right, guys. So have a nice day. I will end this class for today. Bye. Oh.